How close is a neighboring star, really, when the distance is measured in years of light rather than miles? What does it mean to call Alpha Centauri our nearest neighbor, when no human-made object has ever come remotely close to reaching it? And if the mind can cross that gap in a moment, why does the journey in reality stretch into decades, centuries, or even tens of thousands of years? Somewhere in the quiet darkness between stars, a paradox waits patiently. Alpha Centauri is close enough to see with the unaided eye from Earth's southern skies, a faint point of light woven into familiar constellations. And yet it is so distant that even our fastest machines would spend longer traveling toward it than all of recorded human history combined. 4 light-years sounds small when spoken aloud. A simple number, a short phrase. But hidden inside it is a distance so vast that light itself, the fastest traveler the universe allows, must spend years crossing the space between one sun and the next. This is not a journey of engines or trajectories, at least not at first. It is a journey of scale, of patience, of understanding how the universe measures distance, time, and motion. Tonight, the question is not whether Alpha Centauri can be reached in theory, but how long it would truly take to get there, using the tools we have now, the technologies we are building, and the ideas that exist only as careful equations and quiet speculation. Alpha Centauri is not a single star, but a small, stellar family moving together through the galaxy. 2 sun-like stars, Alpha Centauri A and B, orbit one another in a slow, graceful dance, bound by gravity across distances similar to those between planets. Farther out, a dim red dwarf, Proxima Centauri, keeps its own quieter rhythm, glowing faintly yet steadily, closer to Earth than any other star beyond our own sun. In the scale of the Milky Way, this system is almost unimaginably close, a neighboring porch light in a city of hundreds of billions of suns. And yet between here and there lies a stretch of space so empty, so calm, and so vast that it reshapes every familiar idea of travel. To begin understanding that distance, the journey must start at home, with the sun as it fades behind, and with the slow realization that leaving a star is not a moment, but a gradual release. Leaving the inner solar system does not feel like crossing a boundary. There is no line, no sudden darkness, no sign that says the familiar has ended. Instead, the sun's presence thins slowly, almost politely, as distance accumulates. Mercury and Venus fall behind first, their swift orbits shrinking into memory. Earth becomes a pale point, then a suggestion, then nothing at all. Mars fades next, followed by the great gas giants, their immense gravity wells loosening their grip as the outward motion continues. Jupiter's storms and Saturn's rings, once colossal and commanding, collapse into faint specks of reflected light. Uranus and Neptune retreat into the background glow of the Milky Way, indistinguishable from distant stars. Beyond them, Pluto and the scattered worlds of the Kuiper Belt drift like forgotten embers, icy remnants circling far from the warmth that once shaped them. Even here, some light still exists, but it is thin and fragile, more memory than illumination. As the distance grows, time begins to feel different. Days no longer mark progress in any meaningful way. Even years become small units against the scale unfolding ahead. The sun, once dominant, now resembles any other star, a bright point among countless others, its identity preserved only by careful instruments and charts. Beyond the planets lies a realm rarely imagined in everyday thought. A vast spherical halo of icy bodies known as the Oort cloud surrounds the solar system like a quiet archive. Trillions of frozen objects drift here, each one a relic from the system's formation, preserved in deep cold for billions of years. Some are no larger than pebbles. Others rival mountains. They move slowly, loosely bound to the sun by gravity that has grown faint and delicate with distance. Passing through this region is not dramatic. The objects are spaced so far apart that collisions are almost impossible. Instead, the journey feels serene, nearly motionless, as if traveling through a museum where every exhibit is suspended in perfect stillness. These distant comets are nudged only occasionally, stirred by passing stars or subtle galactic tides, sometimes sent inward to blaze briefly near the sun before returning to darkness. At the outer edge of this halo, the sun's influence finally yields. Not abruptly, but gently. The solar wind, a constant stream of charged particles flowing outward from the sun, slows and thins until it blends with the interstellar medium. This boundary, known as the heliopause, is not a wall but a soft transition, like stepping from warm water into cooler air. Beyond it begins true interstellar space. Here, the solar system no longer defines the environment. The ship, probe, or imagined traveler enters the domain between stars, a region governed not by one sun, but by the combined influence of the galaxy itself. Hydrogen atoms drift in extreme isolation. Magnetic fields stretch across vast distances. Occasional cosmic rays pass through, messengers from supernova that exploded long before Earth formed. The sun is now just another light behind, indistinguishable from countless others. Ahead lies a darkness that is not empty, but quiet. And somewhere within that quiet, 4 light-years away, waits the nearest star system, still invisible, still unreachable, still distant beyond comprehension. This is the true beginning of the journey to Alpha Centauri. Beyond the heliopause, space does not suddenly become hostile or chaotic. It becomes subtle, almost delicate. The interstellar medium is so thin that it challenges intuition. On average, a single atom may occupy a space the size of a small room, drifting for years without encountering another. And yet, over distances measured in light-years, even this near vacuum accumulates meaning. Gas, dust, and magnetic fields form a quiet fabric through which stars move and galaxies slowly evolve. The ship now travels not through emptiness, but through a medium that carries the faint memory of ancient stellar births and long extinguished suns. In this region, motion becomes abstract. Speed is no longer felt as acceleration or wind, but as a patient accumulation of distance. Even traveling faster than any spacecraft ever launched, progress feels slow. The stars ahead barely shift. The ones behind fade with equal reluctance. There are no landmarks, no reference points that make the mind comfortable. Only the steady hum of instruments and the unchanging geometry of distant light. Light itself begins to feel precious here. Photons from nearby stars pass silently through the hull, some having traveled for decades or centuries before arriving. Others began their journey long before human civilization existed. Every ray carries a timestamp from the past, meaning that to look outward is to look backward through time. Alpha Centauri, though close by galactic standards, is still seen as it was more than 4 years ago. Its light left before the present moment even existed. As distance from the sun increases, familiar scales collapse. The idea of 1,000,000 kilometers becomes meaningless. Even 1 billion is reduced to a small step. The mind must recalibrate, shifting from planetary distances to stellar ones, from hours and days to years and lifetimes. This recalibration is essential because the journey to Alpha Centauri is not defined by speed alone, but by the patience required to cross a gulf measured in years of light rather than miles of space. To understand how long such a journey would take, It helps to anchor thought to the fastest traveler allowed by physics. Light moves at nearly 300,000 kilometers every second, circling Earth multiple times in the span of a single heartbeat. At that speed, the distance to Alpha Centauri still requires more than 4 years to cross. Seasons pass. Civilizations change. Children grow older. Even for light, the journey is not brief. Now imagine moving far slower than light, as every physical object must. The gap between stars stretches instantly into something vast and humbling. Spacecraft built by human hands do not race across this darkness. They drift. They coast. They glide forward on momentum gathered long ago, inching across a distance that resists haste. This is where the true scale of the question emerges. How long would it take to go to Alpha Centauri is not a single answer, but a spectrum of possibilities shaped by propulsion, energy, mass, and time itself. With today's technology, the journey stretches beyond individual lives. With more ambitious engines, it contracts to decades. With speculative ideas, it approaches the limits set by physics, where time and distance begin to behave differently for traveler and observer alike. For now, the ship continues outward, steady and unhurried. The sun fades further into anonymity behind. Ahead, Alpha Centauri remains invisible, still lost among billions of stars. Yet the path between them is no longer abstract. It has shape, texture, and meaning. It is a quiet ocean of space and time, and crossing it is not a question of courage alone, but of understanding how the universe measures distance, motion, and patience. At this point in the journey, the question of distance begins to merge with the question of endurance. Interstellar space does not resist motion, but it does not reward it either. Once a craft has exhausted its fuel, it coasts indefinitely, carrying whatever speed it managed to gather during its brief moment of acceleration. There is no friction to slow it down, but no further push to make it go faster. Every kilometer gained afterward is the quiet inheritance of earlier effort, a reminder that in space, progress is often decided long before the journey truly begins. The fastest objects humanity has ever launched are small, light, and uncrewed. Voyager 1, launched in the late 20th century, continues to move outward at a speed that once seemed extraordinary. By human standards, it is astonishing, crossing billions of kilometers with steady persistence. By interstellar standards, it is nearly motionless. If Voyager were pointed toward Alpha Centauri, its journey would take on the order of 75,000 years. Entire chapters of human history would unfold while it drifted silently through the dark, its instruments long since fallen quiet, its creators reduced to distant ancestors remembered only in records. This is not a failure of engineering. It is a confrontation with scale. Chemical rockets are powerful, but they release their energy quickly, in minutes or hours. They are designed to escape gravity, to leap from a planet's surface into orbit, to move efficiently within a solar system. They are not built for the long, patient push required to cross the space between stars. Once their fuel is spent, they surrender to inertia, becoming celestial messages rather than vehicles with intent. Even the fastest planetary missions ever flown illustrate this limitation. New Horizons, which crossed the distance to the Moon in mere hours and reached Pluto in less than a decade, still crawls on the galactic scale. At its speed, Alpha Centauri remains tens of thousands of years away. The numbers feel unreal until they are placed against familiar frames of time. Written history spans only a few thousand years. Agriculture itself is younger than the hypothetical duration of such a voyage. By the time a probe arrived, Earth would be unrecognizable, reshaped by climate, culture, and perhaps by entirely new forms of life. And yet, there is something quietly profound in these slow travelers. Voyager continues onward, not because it expects to arrive, but because motion itself carries meaning. It is a time capsule, holding images, sounds, and symbols from Earth, drifting through the interstellar medium as a record of a species that once wondered what lay beyond its sun. Its journey is not measured by arrival, but by persistence, by the simple act of continuing outward into the unknown. To shorten the journey in any meaningful way, propulsion must change in kind, not just in scale. This is where alternative ideas begin to take shape. So the sails, for example, do not rely on fuel carried aboard. Instead, they harvest momentum from light itself. Each photon striking a reflective surface transfers a tiny push. On Earth, such a force would be imperceptible. In the vacuum of space, applied continuously over years, it becomes transformative. A solar sail accelerates slowly but steadily. It does not surge forward and then fall silent. It whispers its way to higher and higher speeds, carried by sunlight or by powerful laser beams projected from afar. Over decades, such a craft could surpass the velocities achievable by chemical rockets, not through force, but through patience. The journey remains long, but it begins to compress from geological time into something closer to a human lifetime. As the sail moves farther from the sun, the pressure of natural sunlight weakens, but the concept evolves rather than ends. Directed energy, focused beams of light from large arrays near Earth or its orbit, could continue to push the sail long after sunlight fades. In this way, propulsion becomes external. The ship carries almost nothing, while the energy that drives it remains behind, anchored to its place of origin. Beyond sails lie more radical ideas. Nuclear pulse propulsion imagines harnessing controlled nuclear explosions to generate thrust, each detonation a measured push against a massive pusher plate. Fusion drives propose igniting the same reactions that power stars, releasing immense energy over long periods. Antimatter engines push the concept further still, converting mass directly into energy with near-perfect efficiency. Each of these approaches reshapes the timeline dramatically, shrinking journeys that once spanned tens of thousands of years into decades, or even less. Yet with greater speed comes new challenges. At a significant fraction of light speed, the interstellar medium is no longer gentle. Dust grains, rare as they are, become dangerous projectiles. Radiation intensifies. Navigation requires extraordinary precision. The universe, once forgiving at slow speeds, demands respect and ingenuity as velocity increases. And still, the promise remains. Somewhere within these concepts lies the threshold where Alpha Centauri ceases to be a distant idea and becomes a destination. Not a place reached by imagination alone, but by carefully layered advances, each building on the last. The journey outward continues, not yet fast, not yet certain, but no longer abstract. It has direction, momentum, and a growing sense that the space between stars, while vast, is not beyond reach. As propulsion concepts grow more ambitious, the nature of the journey begins to change in subtle but important ways. Speed no longer serves only to shorten distance. It begins to reshape time itself. At everyday velocities, time feels absolute, shared equally by all observers. But as a spacecraft approaches a meaningful fraction of light speed, this assumption gently dissolves. Clocks aboard the ship tick more slowly relative to those left behind. Biological processes follow the same quiet adjustment. For the traveler, the voyage compresses. For the distant observer, it stretches outward. The distance between stars remains unchanged, but the experience of crossing it becomes something new. At modest fractions of light speed, this effect is small but measurable. A ship traveling at 1/10 the speed of light would still take roughly 40 years to reach Alpha Centauri from Earth's frame of reference. For those aboard, the passage of time would be slightly shorter. The difference would not feel dramatic, but it would be real. A subtle bending of duration, a reminder that motion and time are entwined more deeply than everyday life suggests. As speed increases further, this effect grows stronger, gently easing the burden of distance for the traveler while preserving it for those who remain behind. At around 1/5 the speed of light, the journey compresses further. From Earth's perspective, a crossing of roughly 20 years becomes possible. For those aboard, time would pass more gently still. The ship would not feel rushed. Days and nights could be maintained artificially. Routine would remain intact. And yet, the stars outside would behave differently. Light from the forward direction would appear slightly concentrated. Distances ahead would seem subtly shortened. Space itself would feel less like an endless gulf and more like a corridor narrowing toward its destination. This is the regime where concepts such as laser-propelled sails and ultra-lightweight probes become especially compelling. By minimizing mass and offloading energy production to distant sources, speed becomes attainable without carrying impossible amounts of fuel. The ship itself becomes almost insubstantial, a wafer of instruments, a sail thinner than fabric, a traveler not by force, but by alignment with physical limits. In this vision, the universe is not fought against, but used carefully, its rules bent gently rather than broken. Yet even here, the journey remains demanding. At these velocities, the interstellar medium can no longer be ignored. Individual atoms, normally harmless, carry significant energy when struck at relativistic speed. Dust grains, though extremely rare, become hazards capable of damaging unprotected structures. Shielding must be clever rather than heavy. Magnetic fields, sacrificial layers, and forward vapor clouds are imagined as ways to absorb or deflect impacts before they reach delicate instruments. The ship becomes an exercise in balance, light enough to accelerate, resilient enough to endure. Beyond this lies an even more dramatic shift. At speeds approaching half the speed of light, the journey to Alpha Centauri compresses to only a few years for the traveler. From Earth's perspective, perhaps a decade or more passes. For those aboard, time flows more gently still. Relativity becomes impossible to ignore. Lengths contract in the direction of travel. The stars ahead seem closer than their measured distances suggest. The universe appears reshaped by motion itself, offering passage through time as much as through space. At such speeds, propulsion must be extraordinary. Fusion drives sustained over long durations. Antimatter engines converting mass directly into thrust. Concepts that today exist mostly on paper begin to define the boundaries of what physics allows. These are not casual technologies. They demand unprecedented control over energy, containment, and stability. They require materials capable of withstanding radiation, heat, and relentless particle impacts. The ship becomes less a vehicle and more a carefully tuned system, existing at the edge of known engineering. And still, speed is not the only solution. Another path accepts long journeys without rushing at all. Generation ships imagine travel not as a sprint, but as a continuity of life. Vast vessels carrying entire communities, self-sustaining and slow-moving, crossing the interstellar gulf over centuries. Children are born aboard. Cultures evolve. Knowledge is preserved and passed forward. The destination becomes a shared inheritance rather than an immediate goal. Alpha Centauri is not reached by the same people who depart, but by their descendants, shaped by the voyage itself. Cryogenic suspension offers a different compromise. Instead of compressing time through speed, it pauses the traveler's experience entirely. Bodies are cooled. Metabolism slows to near stillness. Decades or centuries pass outside, while the sleeper remains unchanged. The ship moves patiently through space, guided by automation, while its human passengers wait beyond time. When they awaken, the journey feels brief, almost instantaneous, even though entire eras may have unfolded elsewhere. Artificial intelligence introduces yet another layer. Machines do not tire. They do not age. They can endure decades of travel without complaint or distraction. Autonomous probes can repair themselves, adapt to damage, and make decisions without constant communication with Earth. They may arrive at Alpha Centauri long before humans do, scouting worlds, mapping orbits, and sending back data across light years of silence. In this way, exploration begins before settlement, knowledge preceding presence. Communication itself becomes part of the journey's texture. Signals travel no faster than light. Messages sent from a ship en route to Alpha Centauri take years to reach Earth. Replies take years more to return. Conversation becomes correspondence. Decisions must be made independently. The ship exists in a bubble of delayed connection, tethered to home by light stretched thin across space. Each message carries weight, not only of information, but of time. As the voyage continues, the sun fades completely into anonymity. It becomes one star among many, no longer special by brightness alone. Ahead, Alpha Centauri gradually emerges from the background. At first, it is indistinguishable from its neighbors. Then, its light grows subtly brighter. Instruments confirm its identity long before the eye could. Two sun-like stars circling one another, their combined glow steady and familiar. Nearby, a faint red dwarf shines quietly, closer than any other star beyond the sun. Approaching this system after such a long passage carries a peculiar stillness. The journey has reshaped perception. Distance has become something lived rather than measured. Time has stretched, bent, or paused depending on the method chosen. Arrival is not triumphant. It is calm, a gentle convergence of motion and patience. The stars do not announce themselves. They simply continue to shine, as they have for billions of years, indifferent, yet welcoming in their own quiet way. In the end, the question of how long it takes to reach Alpha Centauri has no single answer. It depends on speed, on technology, on willingness to wait or to bend time's flow. With today's tools, the journey spans epochs. With emerging ideas, it contracts to decades. With speculative advances, it approaches the limits set by physics itself. Each path reveals something different, not only about the universe, but about how humanity chooses to move through it. The distance between stars is vast, but it is not empty. It is filled with light, particles, fields, and the slow accumulation of meaning. Crossing it is not merely a matter of propulsion. It is an exercise in patience, ingenuity, and humility. Alpha Centauri waits, not as a challenge, but as a reminder that even the nearest stars demand respect for the scale on which the universe unfolds. As the ship closes the long gap between suns, the environment around it grows subtly richer. The interstellar medium, once an abstract idea, becomes something that must be actively navigated. Sparse clouds of hydrogen and helium drift through space, their densities so low they would pass unnoticed near a planet. Yet over light years they leave measurable traces. Magnetic fields thread through these regions like invisible currents, bending charged particles and shaping the slow weather of the galaxy. Cosmic rays arrive from distant supernova, ancient explosions whose energy still ripples outward long after the stars that created them have vanished. None of this announces itself loudly. It is felt through instruments, calculations, and quiet adjustments rather than through spectacle. At higher speeds, this gentle background becomes more assertive. Individual atoms, once insignificant, strike with growing energy. A single hydrogen nucleus can deliver a meaningful jolt at a significant fraction of light speed. Dust grains, though separated by enormous distances, carry the potential to damage exposed surfaces. Protection cannot rely on thickness alone. Heavy shielding would slow acceleration and increase fuel demands. Instead, engineers imagine elegant solutions. Forward-facing vapor clouds that ionize incoming particles before impact. Magnetic fields that curve charged debris away from critical systems. Sacrificial layers designed to erode gradually while preserving what lies beneath. The ship is no longer simply moving through space. It is interacting with it continuously, negotiating passage through a medium that is sparse yet unforgiving of speed. Navigation itself becomes an exercise in precision that borders on artistry. At interstellar distances, even tiny angular errors compound over time. A deviation measured in fractions of a degree near Earth could translate into millions of kilometers at the destination. Stars shift position subtly as the ship moves, requiring constant recalibration. Autonomous systems track reference points, pulsars, and background radiation, updating course with quiet regularity. Human oversight, if present at all, becomes supervisory rather than direct. The ship must think for itself, adjusting continuously to a universe that does not pause for correction. Communication fades into a slow rhythm of delayed exchange. Messages sent home carry snapshots of conditions that no longer exist by the time they arrive. Instructions received from Earth describe circumstances already past. The ship becomes temporally isolated, existing in a present that is inaccessible to those left behind. This separation is not dramatic, but it is profound. It reshapes responsibility. Crews, if aboard, must act with confidence and foresight. Machines must operate with autonomy and resilience. The journey demands trust, not in constant oversight, but in preparation laid down years or decades earlier. As the distance shortens, Alpha Centauri begins to assert itself not as a destination, but as a gravitational influence. Long before the stars are resolved visually, their presence is felt through subtle perturbations. Trajectories curve gently. Instruments detect changes in particle flows and magnetic orientation. The binary nature of Alpha Centauri A and B becomes apparent through their combined pull, a delicate balance that shapes the surrounding space. Farther out, Proxima Centauri announces itself more quietly, its mass small but its proximity unmistakable. The approach does not feel like arrival at a single point, but entry into a region. The system reveals itself gradually, first as an increase in background light, then as a shifting geometry of forces, finally as distinct sources, each star occupying its own place in the sky. Alpha Centauri A shines with a familiar warmth, similar in color and intensity to the Sun, while its companion glows slightly cooler and dimmer. Their orbit unfolds over decades, a slow celestial conversation governed by gravity and time. Around these stars, planets trace paths that are still only partially known. From Earth, their existence is inferred through tiny wobbles and faint dimming events. Up close, they become worlds with scale and presence. Rocky bodies, gas giants, icy remnants, each shaped by the interplay of stellar radiation and gravitational tides. Proxima b, the most discussed among them, orbits close to its red dwarf host, bathed in a light that is weaker yet more variable than Earth's sun. Whether it holds oceans, atmosphere, or life remains uncertain, but its mere existence reshapes the meaning of proximity. A potentially rocky world orbiting the nearest star to our own transforms Alpha Centauri from an abstract goal into a place of immediate scientific interest. The system is not serene in a simple sense. Stellar winds stream outward. Magnetic fields twist and reconnect. Flares from Proxima occasionally flood nearby space with bursts of radiation. Any craft entering this environment must navigate carefully, choosing orbits and trajectories that balance observation with protection. Yet there is order here as well. Stable zones where planets persist for billions of years. Rhythms that repeat predictably. The same laws that govern Earth's sky apply here, indifferent to distance or familiarity. For a ship that has traveled for decades, centuries, or even longer, this region feels almost intimate. The vast emptiness between stars gives way to a complexity that feels earned. The long silence of interstellar space is replaced by a quiet abundance of signals, light curves, particle streams, gravitational gradients. The destination is no longer an idea. It is an environment, rich with information and possibility. At this stage, the question of how long the journey took recedes. Time has already done its work. What matters is not the duration behind, but the presence ahead. The ship, whether crewed or uncrewed, carries with it a history shaped by motion through a universe that measures progress in light years and patience. Arrival is not a conclusion. It is a transition. From travel to observation. From isolation to engagement. From the abstract scale of interstellar distance to the tangible reality of another star's domain. Seen this way, the journey to Alpha Centauri is less about conquest and more about alignment. Aligning technology with physics, expectations with reality, curiosity with humility. The nearest star system does not yield itself easily, not because it resists exploration, but because it exists on a scale that demands respect. To reach it is to accept that some distances cannot be rushed, only navigated with care, preparation, and a willingness to move at the pace the universe allows. Within the Alpha Centauri system, motion takes on a different character. After the long, almost featureless drift between stars, gravity returns as a shaping force. Orbits curve. Velocities change without engines firing. The ship feels guided rather than propelled, drawn into patterns established billions of years before its arrival. Every adjustment becomes smaller, more precise, responding to a gravitational landscape that is no longer uniform but layered and dynamic. The immense emptiness behind gives way to a region where mass, energy, and motion interact continuously. Alpha Centauri A and B dominate this environment together. Their mutual orbit spans decades, a slow and deliberate exchange that shapes everything around them. From a distance, they appear as a single light. Up close, their dual nature becomes unmistakable. Two suns, each exerting influence, each carving zones of stability and turbulence. Between them exist regions where planets cannot persist, their paths disrupted by competing gravitational pulls. Farther out, calmer orbits allow worlds to endure, tracing elegant paths that repeat over cosmic timescales. For any visiting craft, these dynamics must be understood intimately. Trajectories are planned not as straight lines, but as arcs woven through gravitational contours. Fuel is conserved by allowing stars to do the work, bending paths gently rather than forcing corrections. Navigation becomes less about thrust, and more about timing, patience, and precise understanding of motion. A well-planned approach feels almost effortless, as though the ship is being carried rather than driven. Proxima Centauri introduces a quieter complexity. Though gravitationally associated with the larger pair, it remains distant enough to follow its own slow path through space. Its red light carries less energy, but its variability demands attention. Flares erupt unpredictably, sending bursts of radiation through its system. Any craft approaching Proxima b must account for this behavior, choosing observation windows carefully and shielding sensitive instruments from sudden exposure. The environment is not hostile, but it is active, shaped by forces different from those around sun-like stars. Proxima b itself, if it is indeed rocky, as current evidence suggests, occupies a region of intense interest. Its orbit lies close to its star, completing a year in a matter of days. One side may face perpetual daylight, the other endless night. A less atmospheric circulation or axial tilt moderates the extremes. Tidal forces could lock the planet's rotation, reshaping climate and geology. Whether such a world could sustain liquid water depends on many variables, most still unknown. But its existence alone reframes the significance of Alpha Centauri. The nearest star system may host a planet that is not merely theoretical, but tangible, measurable, and perhaps complex. Observation from within the system reveals details impossible to gather from Earth. Spectra sharpen. Atmospheric signatures separate cleanly from stellar noise. Surface features, once hinted at only indirectly, begin to emerge through reflected light and thermal emission. Even barren worlds reveal histories written in crater patterns, mineral distributions, and magnetic traces. Each planet becomes a record of formation and evolution, shaped by its stars and by the broader galactic environment. Yet the significance of arrival extends beyond science. The journey itself has altered perspective. After traveling through a void where nothing changed for years at a time, the richness of a stellar system feels almost overwhelming. Signals arrive constantly. Measurements fluctuate. Forces interact in ways that demand attention. The ship, whether carrying humans, machines, or both, transitions from endurance to engagement, from simply surviving motion to actively interpreting environment. Time, too, feels different here. The long intervals of interstellar travel compress into moments of rapid discovery. Data accumulates faster than it can be analyzed. Decisions carry immediate consequences. The universe, once distant and abstract, becomes present and responsive. This contrast highlights something fundamental about exploration. The effort required to reach a destination often far exceeds the effort required to study it. Patience gives way to focus. Stillness yields to complexity. From this vantage, Earth feels unimaginably remote. Signals sent home will take years to arrive, carrying information about worlds that no human eye has ever seen directly. By the time responses return, circumstances will already have changed. The explorers exist in a kind of temporal independence, acting within a present that cannot be shared in real time. This separation is not isolation, but autonomy. The journey has carried not just hardware, but responsibility, outward into the galaxy. Looking back toward the direction of the sun, it is no longer possible to pick out which star is home without instruments. The Milky Way presents itself as an even field of light, dense with suns, each with its own retinue of planets, dust, and history. Alpha Centauri is simply one of these, distinguished only by proximity and familiarity. This realization reshapes the meaning of arrival. Reaching the nearest star does not place humanity at the edge of the galaxy. It merely moves the center of attention slightly outward. The question that began the journey, how long it takes to reach Alpha Centauri, now feels less like a calculation and more like a reflection. The answer depends on how time is defined, how motion is achieved, and what is valued along the way. A slow probe takes tens of thousands of years but requires little complexity. A fast craft crosses in decades but demands extraordinary precision and energy. A generation ship measures duration in lifetimes. Cryogenic travel erases subjective time altogether. Each approach reveals a different relationship with distance. What remains constant is scale. 4 light-years is not trivial. It resists simplification. It cannot be reduced to a single number that carries intuitive meaning. It must be lived through thought, through physics, through careful imagination. The space between stars is vast, not because it is empty, but because it unfolds at a pace that challenges human expectation. Crossing it requires not only propulsion, but acceptance of the universe's rhythm. Alpha Centauri does not mark an ending. It marks a threshold. Beyond it lie countless other systems, each farther than the last, each demanding even greater patience and ingenuity. If the nearest star requires decades or centuries to reach, the galaxy as a whole demands something more enduring than speed alone. It demands continuity of knowledge, of curiosity, of purpose, passed forward across generations. In this sense, the journey to Alpha Centauri is not about leaving home. It is about extending it, carrying understanding outward, learning how to exist within distances that once seemed unbridgeable. The ship that arrives here, whatever its form, represents more than travel. It represents alignment between imagination and reality, a proof that even within the limits imposed by physics, motion between stars is possible, provided time is treated not as an enemy, but as part of the path itself. And so the system shines quietly ahead, 2 sun-like stars and their faint companion continuing their ancient motions, indifferent to the arrival of a visitor, yet offering an abundance of information to those prepared to crowd. Observe. The journey that led here has already done its work. It has reshaped scale, patience, and perspective. What comes next is not a question of distance, but of attention. Beyond the immediate science of orbits and atmospheres, the Alpha Centauri system quietly reframes the meaning of proximity in the universe. 4 light-years is not a neighborhood in any human sense. It is a distance that dissolves intuition. And yet, standing within this system, the gulf that once seemed insurmountable now exists entirely behind. The crossing has already happened. The space between suns, once imagined as an endless barrier, has become a traversed medium, transformed from abstraction into experience. From within another star's domain, the Milky Way reveals itself differently. The galaxy is no longer a backdrop or a photograph flattened into a band of light. It becomes an environment, a structured system of motion, density, and time. Stars move together in slow arcs around a common center. Gas clouds drift and collapse. Stellar nurseries glow faintly where gravity has gathered material tightly enough to ignite new suns. Alpha Centauri is not isolated. It is one note in a vast, rotating chorus. This realization changes the emotional texture of the journey. The fear, often associated with interstellar travel, fades, replaced by something quieter and more expansive. The universe is not a hostile void punctuated by rare islands of matter. It is a continuous medium, sparse but connected, governed by the same laws everywhere. The same physics that holds Earth in orbit holds Alpha Centauri together. The same atomic structures that form oceans and rocks here exist there as well. Distance separates, but it does not estrange. The technologies imagined across this gulf now feel less like fantasies and more like extensions of patience and understanding. Each method represents a different philosophy of motion. Chemical propulsion embodies urgency and limitation. Solar sails express trust in accumulation. Fusion and antimatter reflect mastery over fundamental forces. Generation ships emphasize continuity over speed. Cryogenic suspension treats time as something negotiable. Artificial intelligence reframes presence itself, allowing exploration without biological constraint. None of these paths is inherently superior. Each carries trade-offs shaped by energy, risk, and values. Seen from this distance, even the longest journeys begin to feel coherent. A voyage lasting tens of thousands of years seems impossible only when framed against a single lifetime. Against the age of stars, it is modest. Alpha Centauri itself has existed for billions of years. It will continue to shine for billions more. From that perspective, a slow probe drifting patiently across the void is not late. It is precisely on time. This shift in scale invites a different kind of ambition. Not the ambition of speed alone, but of continuity. Interstellar travel becomes less about heroic moments and more about systems that endure. Knowledge that survives transfer across centuries. Technologies designed not for spectacle, but for reliability. Cultures that value preservation as much as innovation. In this framing, the first successful journeys between stars may not be dramatic. They may be quiet, methodical, and largely unnoticed by the generations who initiate them. The silence of interstellar space reinforces this idea. There is no rushing wind, no visual blur, no sensory feedback to reward haste. Progress is measured through data, through gradual changes in light and particle density, through calculations confirmed slowly over time. The universe offers no shortcuts. It responds only to consistency and respect for its limits. Within the Alpha Centauri system, this patience is rewarded with richness. The variety of stellar behavior, the subtle interplay of radiation and gravity, the diversity of planetary outcomes, all reveal how much remains to be learned, even in the nearest stellar neighborhood. Each measurement taken here sharpens understanding not only of this system, but of countless others like it scattered across the galaxy. Alpha Centauri becomes a reference point, a calibration of expectation, a bridge between theoretical models and lived observation. The act of reaching another star also reshapes identity. A species that can cross interstellar space no longer belongs exclusively to one sun. Its frame of reference expands. Home becomes plural, distributed across systems connected by light rather than geography. This does not diminish the significance of Earth or the Sun. It contextualizes them. They become part of a broader structure rather than the entirety of existence. Yet even with this expansion, humility remains unavoidable. The galaxy is vast beyond comprehension. Alpha Centauri is close only in relative terms. Beyond it lie thousands of stars within 100 light-years, millions within 1,000, and hundreds of billions across the Milky Way. Each additional step outward multiplies difficulty rather than reducing it. The nearest star is not a gateway that makes the rest easy. It is a lesson in scale, repeated at higher levels of complexity. This is why the question of travel time remains central. Not as a technical challenge alone, but as a philosophical one. How much time is acceptable to invest in a journey whose benefits may not return to its originators? How much autonomy can be entrusted to machines or distant crews? How much uncertainty can be accepted when feedback loops span decades? These are not questions physics can answer on its own. They belong to the realm of collective choice. The journey to Alpha Centauri shows that motion between stars is possible, but not casual. It requires alignment between intention and reality, between desire and patience, between imagination and restraint. Every proposed solution carries with it a worldview. Speed values immediacy. Endurance values legacy. Automation values continuity without presence. Human crews value experience itself, even when costly. Standing within another star's light, these distinctions feel less theoretical. They become practical considerations shaped by exposure to scale. The universe does not favor one approach over another. It accommodates all that respect its boundaries. The constraint is not hostility, but indifference. The stars will not bend to ambition. They simply exist, waiting to be approached on their own terms. Alpha Centauri, in this sense, is not an endpoint. It is a mirror. It reflects what is required to leave one system and enter another. It demonstrates that distance is not merely space to be crossed, but time to be inhabited. That the journey itself alters those who attempt it, whether biologically, culturally, or conceptually. As the system continues its quiet motions, indifferent to observation, the broader implication becomes clear. Interstellar travel is not about conquering distance. It is about learning how to coexist with it. To move within a universe that measures progress in light years and patience, rather than in speed and spectacle. The nearest star teaches this lesson gently, simply by being there, 4 light years away, waiting without urgency, offering no reward except understanding to those willing to take the long way across the dark. As time passes within the Alpha Centauri system, the distinction between traveler and environment begins to soften. The ship, having endured the long transit through interstellar space, now exists within a region where change happens on observable scales. Stellar winds fluctuate. Radiation levels rise and fall with stellar activity. Orbital mechanics introduce cycles that repeat with comforting regularity. After the profound stillness of the void, this subtle dynamism feels almost alive. Space is no longer a uniform darkness, but a layered landscape shaped by energy, motion, and gravity. This contrast highlights one of the quiet truths of interstellar travel. Most of the journey is spent in near sameness. Years pass with little variation beyond slow instrument readings and the gradual accumulation of distance. Arrival, by comparison, is rich and information-dense. The universe seems to reward patience with complexity. The long wait gives way to discovery not as spectacle, but as texture, a depth of detail that could only be appreciated after enduring the silence between stars. Within this system, the passage of time is marked differently depending on the traveler's method. For an automated probe, years are little more than data intervals. For a generation ship, decades represent full cycles of life, education, and memory. For a cryogenically suspended crew, time here feels almost discontinuous, as if the journey collapsed into a single step. For relativistic travelers, time has been reshaped entirely, stretched and compressed according to velocity. All arrive at the same place, yet none share the same experience of getting there. This multiplicity of timelines underscores how travel duration is not solely a physical measure. It is psychological, cultural, and biological. A journey of 40 years is short for a civilization, long for an individual, and trivial for a star. When considering Alpha Centauri, the question of how long it takes becomes inseparable from who is traveling and how they perceive time itself. The universe offers no preferred frame of experience. It allows many to coexist, each valid within its own context. The engineering lessons embedded in this journey linger as well. Systems designed to function for decades without maintenance reveal which technologies endure and which fail. Materials exposed to cosmic radiation and micro-impacts tell stories written slowly into their structure. Redundancy proves more valuable than elegance. Simplicity outlasts complexity. Designs that assume repair, adaptation, and imperfection survive where rigid precision does not. Interstellar travel rewards humility in design as much as ambition in concept. From this perspective, Alpha Centauri becomes more than a scientific target. It becomes a proving ground, a place where ideas about propulsion, autonomy, and endurance are tested not in theory, but in reality. Success is not defined by speed alone, but by continuity, by whether knowledge arrives intact, by whether systems function as intended after years of isolation, by whether the journey itself expands understanding rather than merely achieving arrival. As observation continues, the system's planets reveal themselves gradually. Some may be barren, stripped of atmosphere by radiation, or locked in gravitational configurations that prevent stability. Others may show signs of retained gases, magnetic fields, or thermal gradients that hint at more complex histories. Each world, regardless of habitability, contributes to a broader understanding of planetary formation and survival. Alpha Centauri becomes a microcosm of galactic diversity, offering insights applicable far beyond its immediate neighborhood. The presence of Proxima Centauri adds a further layer. Its smaller mass and frequent stellar activity remind observers that proximity does not guarantee gentleness. Habitability is not defined by distance alone, but by interaction. Radiation, tidal forces, atmospheric retention, and magnetic shielding all play roles. Worlds here may endure conditions unfamiliar to Earth, yet still persist. This reinforces a broader lesson. Life, if it exists elsewhere, may not mirror terrestrial expectations. The universe accommodates variety far beyond familiar patterns. Signals sent back toward Earth now carry immense weight. Each transmission represents years of planning, execution, and trust. There is no opportunity for correction after the fact. What is sent must be sufficient. What is learned must be distilled carefully. Communication becomes deliberate, almost ceremonial. Data packets travel across light years, carrying not only measurements, but the accumulated effort of an entire journey. By the time such messages arrive, the context on Earth will have shifted. New technologies may exist. New questions may dominate. Yet the information remains valuable precisely because it bridges eras. Interstellar communication becomes a conversation across time rather than space. Each exchange acknowledges delay as an inherent feature rather than a flaw. The universe does not permit immediacy at this scale. It insists on patience. As understanding deepens, the broader implication settles quietly. Reaching Alpha Centauri does not shrink the galaxy. It enlarges awareness of how vast it truly is. The nearest star system serves as a reminder that proximity is relative, and that even the closest destinations require commitment measured in years, generations, or lifetimes. The achievement lies not in minimizing this commitment, but in choosing to accept it. In this way, the journey reframes exploration itself. It is no longer about conquering distance, but about sustaining intention across time. About building systems, cultures, and knowledge that persist long enough to matter. Alpha Centauri stands not as a prize to be claimed, but as a milestone demonstrating what is required to move beyond the single sun. The stars beyond remain just as distant as before. Nothing about reaching the nearest one makes the others easier. Yet something fundamental changes nonetheless. Distance becomes experienced rather than imagined. Light years become lived intervals rather than abstract numbers. The universe remains vast, but it is no longer unreachable. It is navigable, provided movement is approached with patience, care, and respect for the scale on which everything unfolds. As the system continues its quiet motion, the journey that led here settles into perspective. It was not a race, nor a test of endurance alone. It was a lesson in alignment between physics and ambition, between time and expectation. Alpha Centauri does not answer the question of how long it takes to reach the stars. It teaches that the answer depends entirely on how time itself is understood, and how willing one is to move at the pace the universe allows. As exploration within the Alpha Centauri system continues, another realization begins to settle, one that has less to do with propulsion or engineering and more to do with perspective. The journey has not merely crossed space, it has crossed assumptions. Distances once thought of as impossibly large have become traversable under the right conditions. Time once treated as a rigid constraint has revealed itself as something flexible, shaped by velocity, biology, and choice. Even the idea of presence has shifted, no longer requiring a living human body to arrive first in order for exploration to begin. This reframing carries consequences that extend far beyond a single star system. If Alpha Centauri can be reached in decades using advanced propulsion, then dozens of stars within a similar radius become conceivable targets. Each one represents not just a destination, but a branching of possibility. Some may host planets. Some may be quiet and empty. Others may hold environments that challenge every existing model of habitability. The nearest star is no longer unique. It becomes the first entry in a growing catalogue of reachable systems. Yet reachability does not imply immediacy. Even with optimistic technologies, interstellar travel remains deliberate rather than casual. A mission launched toward one star cannot be redirected easily to another. Commitment is required long before outcomes are known. Choices must be made years in advance, often without the possibility of revision. This demands a form of planning rare in modern human experience, one that stretches intention across decades and accepts uncertainty as an inherent companion. Within this framework, the notion of return becomes ambiguous. Many interstellar missions may be one way by necessity. The energy required to decelerate, reorient, and travel back to the point of origin can rival or exceed that of the outward journey. A crewed mission that arrives may not be designed to leave again. A probe may transmit its findings until its power fades, never retracing its path. Exploration, in this sense, becomes an act of extension rather than visitation. Humanity does not go out and come back unchanged. It spreads outward, leaving traces rather than footprints. This challenges traditional narratives of travel. The familiar arc of departure, journey, arrival, and return does not always apply at interstellar scales. Instead, exploration resembles growth. Slow, branching, irreversible. Knowledge flows back even when travelers do not. Influence extends outward even when bodies remain behind. The stars are not visited in the same way continents once were. They are connected to gradually through light, data, and a persistence of intention. Over long timescales, this process reshapes civilization itself. A species capable of launching missions that last longer than individual lifetimes must develop institutions that endure just as long. Records must be preserved across generations. Scientific goals must remain coherent despite cultural change. Languages may evolve. Priorities may shift. Yet the mission continues, carried forward by continuity rather than urgency. Interstellar travel thus becomes a test not only of technology, but of cultural resilience. Alpha Centauri, in this light, represents a boundary between eras. Before it, humanity exists entirely within the influence of one star. After it, that exclusivity ends. Even if no permanent settlement is established, the act of reaching another sun alters the frame of reference permanently. Home is no longer singular. It becomes distributed, defined less by location and more by connection. The physical realities of space reinforce this lesson. The interstellar medium does not care about intent. Radiation does not pause for curiosity. Time does not compress out of sympathy. The universe responds only to interaction governed by law. This neutrality is not hostile. It is consistent. It allows progress, but only under conditions that respect scale and limitation. The patience required to cross 4 light-years is not imposed arbitrarily. It is a consequence of how space and time are structured. Seen this way, the slow nature of interstellar travel is not an obstacle to be overcome, but a filter that shapes behavior. It discourages haste. It favors preparation. It rewards designs that anticipate failure and recovery rather than perfection. It aligns exploration with long-term thinking rather than immediate gratification. In a universe measured in billions of years, such alignment may be essential for survival. As understanding deepens, even speculative technologies take on a different tone. Fusion drives, antimatter propulsion, and laser-accelerated sails are no longer imagined as shortcuts, but as ways to work within physical limits more effectively. They do not eliminate distance. They negotiate with it. They trade mass for energy, time for complexity, risk for possibility. Each approach represents a different compromise, a different answer to the same question. How long it takes to reach Alpha Centauri is therefore not just a matter of speed. It is a reflection of values. A fast mission prioritizes immediacy and experience. A slow mission prioritizes persistence and legacy. An automated mission prioritizes knowledge over presence. A crewed mission prioritizes perception and meaning. None is inherently superior. Each reveals something about what is considered important. As the system's stars continue their quiet motion, indifferent to observation, the final shape of the journey becomes clear. The crossing of interstellar space is not a singular achievement, but a process. It unfolds over time, across generations, through layered efforts that build upon one another. Alpha Centauri is reached not by one invention or one mission, but by the accumulation of understanding that makes such missions possible at all. The question that began this journey, how long it would take to go to Alpha Centauri, now rests within a broader context. With present technology, the answer stretches beyond recorded history. With emerging concepts, it contracts to decades. With speculative advances, it approaches the boundaries of physics. But beneath all these answers lies a quieter truth. The universe does not measure journeys the way humans do. It measures them in continuity, in persistence, and in the steady unfolding of motion across vast scales. Alpha Centauri remains where it has always been, shining steadily in the darkness. What changes is not the star, but the relationship to it. Distance becomes navigable. Time becomes something to inhabit rather than escape. And the journey, once unimaginable, becomes a natural extension of curiosity shaped by patience. The nearest star does not promise easy access to the galaxy. It offers something more subtle, a lesson in how movement, time, and understanding must align before the space between suns can truly be crossed. As the long arc of the journey draws toward its final understanding, the scale of what has been considered begins to settle gently into place. 4 light-years no longer feels like a single number. It feels like a layered experience. A sequence of environments, constraints, and choices that unfold slowly, each revealing something different about the universe and about the travelers who attempt to cross it. What began as a question of distance became a meditation on time. Not only on how long a journey lasts, but on how time is experienced, preserved, paused, or reshaped depending on the path chosen. A probe feels no years pass at all. A sleeping traveler experiences none of them. A generation ship lives them fully, one after another, weaving the voyage into the fabric of daily life. A relativistic craft bends them gently, compressing decades into something shorter without ever escaping their reality entirely. This diversity of experience reveals something essential. Interstellar travel is not one story. It is many overlapping stories, all valid, all constrained by the same physical laws, yet lived in profoundly different ways. The universe permits these differences without preference. It allows slow drift and rapid passage. It allows endurance and immediacy. What it does not allow is neglect of scale. Every approach must answer to distance, energy, and time, even when those answers take unfamiliar forms. Alpha Centauri, as the nearest star system, serves as the first true test of this relationship. It is close enough to be imagined clearly, yet far enough to resist simplification. It forces careful thinking. It demands respect for limits. It refuses to be reduced to metaphor alone. To reach it is to accept that space is not something to be crossed casually, but something to be inhabited thoughtfully, even temporarily. This acceptance reshapes ambition. The desire to explore does not vanish, but it matures. Instead of seeking speed for its own sake, the focus shifts towards sustainability, reliability, and continuity. Missions are designed to last not just long enough to arrive, but long enough to matter. Data must survive decades. Systems must function without intervention. Knowledge must be transmitted across time delays that stretch patience thin. The success of such endeavors is measured not in headlines, but in persistence. In this light, the idea of progress itself changes character. Progress becomes cumulative rather than immediate. Each mission informs the next. Each technological advance narrows uncertainty rather than eliminating it. Alpha Centauri does not open the galaxy overnight. It opens a method, a way of thinking about distance that can be extended carefully outward, star by star, without illusion of ease. The quiet nature of this progress mirrors the quiet nature of space itself. There are no grand thresholds crossed with fanfare. No moment when the universe suddenly feels smaller. Instead, familiarity grows slowly. The once unimaginable becomes understood, then navigated, then integrated into a broader picture of how the galaxy is structured and how motion unfolds within it. This is why the journey matters, even if it remains rare. Even if only a handful of missions ever cross the gap to Alpha Centauri, the act itself alters perspective permanently. Humanity becomes a species that has experienced more than one stellar environment directly. That shift cannot be undone. It reframes questions about origin, belonging, and future in ways that cannot be replicated by observation alone. From this vantage, the long silence between stars no longer feels empty. It feels intentional, a vast buffer that enforces deliberation. That discourages haste. That ensures any attempt to cross it is made with care. In a universe where energy is finite and distances are immense, such enforced patience may be a quiet form of balance rather than a barrier. As the final reflections settle, the original question returns one last time, now transformed by everything it has carried along the way. How long would it take to go to Alpha Centauri? With the tools of today, The answer stretches beyond individual lives and even civilizations. With emerging technologies, it contracts to decades. With speculative advances, it approaches the limits where time itself becomes part of the solution. Yet none of these answers stands alone. Each describes not only a duration, but a relationship between traveler and universe. The nearest star does not offer a shortcut to the cosmos. It offers a lesson in scale. It teaches that movement through space is inseparable from movement through time. That distance is not an obstacle to be conquered, but a condition to be understood. And that exploration at its deepest level is not about arrival, but about alignment with the rhythms that govern everything. Alpha Centauri continues its quiet motion, its stars orbiting one another as they have for billions of years. They neither await nor resist attention. They simply exist. What changes is the awareness brought to them. The understanding that the light seen from Earth has traveled years to arrive. That any traveler who reaches them will have lived through a story shaped as much by patience as by propulsion. And so the journey ends not with resolution, but with calm perspective. The distance between stars remains vast. The universe remains indifferent. Yet within those truths lies something steady and reassuring. The space between suns can be crossed, not quickly, not easily, but deliberately. And in learning how to cross it, something essential is gained. Not mastery over the cosmos, but a deeper harmony with the way it unfolds. The stars will continue to shine long after questions fade. The paths between them will remain open to those willing to move at the pace they require. And Alpha Centauri, the nearest of them all, will remain what it has always been. A quiet reminder that even the closest destinations in the universe ask for patience, understanding, and time. As this long consideration gently settles, one final understanding rises above the details of engines, velocities, and years counted on clocks. The journey to Alpha Centauri is not defined by a single technological breakthrough or a single moment of departure. It is defined by continuity, by the ability to carry intention forward across spans of time that exceed individual lives, careers, and even generations. Every method imagined, from the slow drift of today's probes to the speculative reach of near light speed travel, shares one quiet requirement: trust. Trust that systems will endure. Trust that knowledge will be preserved. Trust that the meaning of the journey will survive long enough to be fulfilled. Interstellar space does not allow improvisation. It rewards preparation and punishes haste. In this sense, the stars quietly shape the behavior of those who reach for them. Alpha Centauri, though nearest, makes this lesson unavoidable. 4 light-years is close enough to feel reachable, yet distant enough to resist shortcuts. It refuses to be treated casually. Any attempt to cross the gap demands a decision about time itself, whether time is lived fully, paused entirely, stretched by motion, or surrendered to machines that do not feel it at all. Seen this way, the question of travel duration becomes less technical and more reflective. How long a journey takes depends on what is valued along the way. Speed prioritizes immediacy and experience. Slowness prioritizes continuity and legacy. Automation prioritizes knowledge without presence. Human passage prioritizes meaning, even at great cost. None of these choices is imposed by the universe. They are chosen in response to it. The space between stars does not judge these choices. It simply enforces consistency. A slow journey must truly be slow. A fast journey must account for risk. A generational voyage must support life across centuries. A machine Scent alone must be capable of learning and repair. The universe accepts all approaches that respect its structure and rejects those that do not. This is why Alpha Centauri matters, even before any ship arrives. It forces clarity. It exposes assumptions about progress, patience, and purpose. It reveals that exploration at this scale is not about proving dominance or speed, but about alignment with reality. About learning how to move within a cosmos that is vast, ancient, and largely indifferent. In that indifference lies a quiet gift. The universe does not hurry. Stars do not age on human schedules. Distance does not compress to meet desire. Instead, everything unfolds at its own pace. To travel between stars is to step into that rhythm, to accept that some goals require waiting and that waiting itself can be meaningful. The nearest star does not promise ease. It promises perspective. It shows that the boundaries humans feel most strongly are often temporal rather than spatial. That the challenge is not crossing space, but sustaining intention across time. And that once this is understood, distance becomes navigable, not through force, but through patience. As the light of Alpha Centauri continues its 4-year journey toward Earth, unchanged and unhurried, it carries no awareness of questions asked or answers imagined. It simply arrives, steady and constant, year after year. That light is a reminder, not of how far away the stars are, but of how long they have been shining and how much time remains. The journey to reach them will always ask something in return: time, energy, care, foresight. But in giving those things, something equally profound is gained. Not ownership of the stars, but participation in their scale. An understanding that to explore the universe is not to conquer it, but to learn how to move within it, without impatience. Alpha Centauri will remain where it is, 4 light-years away, quiet, persistent, and unchanged by curiosity alone. What changes is the relationship to it. The awareness that distance can be crossed, that time can be shaped, and that exploration is possible when expectation is aligned with reality. And so the final answer settles gently into place. How long would it take to go to Alpha Centauri? As long as it needs to. As long as physics allows. As long as patience endures. The stars are not waiting. They do not need to. They will still be there, shining steadily, long after questions drift away. And for those willing to move carefully, deliberately, and with respect for scale, the path between suns will remain open, not as a challenge to be beaten, but as a journey to be understood.